Okay, Bismillahirrahmanirrahim. Here we start our first chapter. First chapter of formal methods. Okay, as you know, this subject is compulsory, especially for those who are taking a major subject. Major subject. Okay, for today, okay, we are looking into several subtopic here. First one, I will introduce to you about the overview of formal method. Okay, what is formal method? What is the main definition of formal method? Okay, and then secondly, I also describe some of the advantages and some of disadvantages of formal method lah. This one is very important to describe an overview of formal method, and then it sometime appear in your final assessment lah. Okay, wait, Okay, then after that, I will discuss about some of formal methods supporting tools like Z tools, okay, Vienna development methods, okay, and several of formal method tools. Draw, I cannot draw. Wait, set to one. Okay, okay. Okay, can you see my slide? Boleh nampak ke slide saya? Nampak. Okay, this one is important to know advantages, and then we have some of disadvantages. Advantages. Okay, sorry, my handwriting is very bad. Boleh can you ni boleh baca ke? Okay, and then why formal method is important? Because we use the formal method, especially for software development. Okay, and then we use the formal method also because of the formal method is very familiar in software system design. Especially we are using rigorous specified mathematical methods. Okay. Okay, this one is an overview of formal methods. Okay. We have a specification verification. Okay, specification verification is we are designing using a mathematical model to build a software and hardware system. Specification verification. This one for especially for okay software and hardware. Okay, and then the formal method also use approach to software engineering that apply mathematical method or technique to process the development or developing a complex software system. Okay, basically the complex software system usually using the semantic and the common problem for the semantic. Later I discuss. I tell about the semantic. Is a problem. The main problem is the delay. Okay, the main problem is the delay. The approach uses a formal specification language. We using the specification language. Okay, specification language to define the characteristic of the system. Characteristic. Kita nak tengok dia punya karakteristik sifat-sifat dia lah. Okay. Nanti kita akan tengok lebih lanjut lah. Okay, so far do you have any question? Ada sebarang soalan ke setakat ni? Boleh eh? Damrin okey ke? Okay, and then we have several categories in the formal method. For example, we have abstract state machine (ASM). Okay, saya buka satu lagi lah. Okay, we have several categories of formal method and notation. Saya turunkan sekejap. So we have several formal method and notation. Notation. Okay, for example, we have ASM. ASM stand for abstract state machine. And then we have actor model. Okay, and then we have B method and so on. B method. Okay. Okay, why we use the formal method? Formal method have many advantages. Okay. They help the disambiguate the system, help to uh, understand more about the system specification and articulate implicit assumption. Okay. This one, why? Why we use formal method? FM stand for formal method. Okay, because they have to define the system. Define the system and articulate implicit assumption. Okay, kita akan banyak guna assumption dalam formal method ni. Okay, assumption and apa? Assumption and semantic. Okay, so far ada soalan ke tentang formal method ni? Benar. Okay, and then after we define the system and articulate the implicit assumption, uh, we want to use the formal logic to write the specification. After that, we use the okay, after that after we define, we include to write the specification. Write the specification, and then after that, after we write the specification, we want to prove our main prove the program. Okay, the proving technique banyak kita gunakan dalam formal method. Okay, proving technique nanti kita akan tengok apa beberapa apa uh, proving techniques yang mana proving techniques ni is important because of kita nak tengok, we want to see either the system is good or not. Okay, and then the main question that you might ask, why formal method are required for software development? Okay, why? Agak-agaknya siapa tahu? Fatin, why? Why formal method is important and required for software development? Kenapa? Fatin Najwa ada? Kenapa agaknya penting? Okey, lagi? Okey. Okey, okey, betul lah tu. Tapi yang paling penting untuk formal method ni, kenapa diperlukan, why formal method are required for software development is to systemize the system uh, into phases of software development lah. Dia untuk kita susun. We want to arrange back the rigorous process. Okay, and avoid to overlooking critical issues. Okay, avoid to overlooking the critical issues. For example, we want to record a various assumption and decision. Okay, kita nak elakkan daripada kita terlepas daripada fasa-fasa penting dalam software development process lah. Okay. Okay, and then okay, that one is why formal method are required lah. Ini kita buang lah. Sekejap saya tulis boleh? Why formal method important and required. Okay. Okay, this one is to minimize and boleh baca ke ni? Boleh baca ke tulisan saya? Okay. Okay. And then role of formal method. Formal method are system basically for the system. Basically targeted for the system technique that uses rigorous specified mathematical model to build software and hardware system lah. Yang ni macam yang saya terangkan as I explained before. Okay, to develop rigorous specified mathematical model, and then formal method use mathematical proof. Okay, and then we in formal method we use the mathematical proof. Proof. Okay, this one as a complement to systems testing. Complement to system testing. Okay, in order to ensure the correct behavior. Okay, this one to ensure the correct behavior. Math proof to ensure the correct behavior. Correct behavior in terms of system behavior. Okay. Okay, and then what is a formal method? Formal method yang ni saya dah explain tadi. Formal method uh, uh, being used for designing and to ensure the system uh, 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 in order to ensure the correct behavior. But here, what is a formal method? Formal method can be a foundation for designing safety critical system lah. Okay, designing safety critical system. For example, we have aerospace. Why aerospace is very critical system? Aerospace ni kenapa dia jadi sebahagian daripada critical system? Siapa tahu? No, because it involving the life lah. Okay, life. Okay, kalau kamu tengok aerospace ni kan very critical sebab dia melibatkan nyawa. Nyawa. For example, automotive. Automotive pun same. If you go and read about the Tesla, Tesla also have a form method approach to ensure the autonomous punya driving tu safe lah. Okay. And then other than that, we have healthcare. Healthcare kalau kita tengok heart monitoring system, heart monitoring system also using the formal method punya approach lah, because of kalau kita silap baca apa heartbeat, okay, and it involve the life, it's very critical. Other than that, kalau kita tengok railway pun sama ya. Railway ni kereta api lah. It also involve the very and highly critical system because it involve the passengers. Passengers. Okay, and then it also important and vital for to be a foundation for describing a complex system lah. Yang ni saya dah terangkan tadi. Untuk complex system, uh, complex system ni contoh complex system apa dia? Siapa tahu? Complex system ni yang kompleks lah, yang system whose behavior difficult to model. For example, we have modern energy and telecommunication infrastructure yang very complex lah. Contohnya kalau kita nak tengok, if you want to see the NASA apa rocket system is very complex. Okay, complex system and then form method can be a foundation for the complex system. And then number three, provide support for program development such as proof and model checking. Yang ni kita akan tengok banyak lah, proof and model checking. Okay, for formal method, we are looking a lot of proof and model checking. Okay, kenapa kan kita nak tengok model checking? Okay, basically for program development ni, such as proof and model checking. This one. Okay, is to verify if the abstract representation of the system is correct relative to formal specification describing the desired expected system behavior. Ni semua kita nak tengok dia punya system behavior. Okay. Yang macam saya explain tadi, we are looking for the system behavior by using the model and abstraction. Okay. Model by using model and also abstraction. Okay, this one is just a simple explanation of what is form method. Form method basically is involving model checking and property checking. This method for checking whether a finite state model in the system meet a given specification, and also known as a correctness lah. Okay, and then nanti kita akan tengoklah what is finite state machine, what is directed graph, and so on. Okay, and then formatted used to use the mathematical proof, mathematical proof as a complement. Yang ni saya dah terangkan tadi, as a complement to system testing. Okay, in order to ensure the correct behavior. And then formatted refer to a variety mathematical modeling technique, that are applicable to computer system design. Okay, yang ni kita dah tengok tadi yang at the first ni, we are using ASM, we are using actor model, and then we are using B method. And then formatted a mathematical approach. Basically, we using the mathematical and abstraction. Okay, for verifying and abstract representation. Okay, we support the rigorous specification, design, and verification of the computer system. Okay, basically, when you talk about the formal method, we are looking for the approaches, both software and system. Okay, ada soalan ke setakat ni? Do you have any questions so far? Boleh ke? What? Yes. ASM. ASM not application. ASM model. ASM model stand for automatic simulation model. This one is automotive. Okay. This one real-time model for vehicle development. Eh? Okay, automotive simulation model. Automotive. Okay, after this, you need to do the sum of mind mapping, mind mapping, and upload to Padlet. Nanti jangan lupa after the class, you do the reflection. Okay, basically, formatted techniques. We use the several techniques to use to model a complex system as a mathematical entities. Okay, during the formal specification, okay, basically an engineer or designer rigorously define a system using a modeling language, typically by using formal and mathematical syntax, okay, and semantics to eliminate the imprecision and ambiguity. Okay, precision, semantic. What is semantic? Okay, for your information, semantic model is a model of method of structuring data in order to represent a specific logical model. Okay, semantic. certain data in order to represent. Okay. Okay, for the formal method continuation, we have several stages in a formal method. Basically, we are discussing about technique and tools based in mathematics and formal logics. Okay, we can assume the forms of a level of rigorous model. First one is informal. Basically, this one is a very low level. And then, secondly, we go for the low and medium and high. Lah. Okay. Okay, so far ada soalannya. Formulator ni banyak kita belajar tentang ni lah, tentang semantic and abstraction. Okay. This one is basically we use the modeling language. Modeling language ni basically kita akan gunakan mathematical and semantic. Okay, for the model, this one I have explained to you is a approach to software engineering that applies the mathematical or technique to the process of developing a complex software system. And then it uses approach use a formal specification language to define each characteristic of the system, which means that from the informal, low and medium and high, we are using several approach that is vary, especially for the complex system. We use much more formal specification language, especially to model and to divide the complex system into the smaller module. Okay, this one is to ease the software engineer and also software developer to check either the system behavior is correct or not. Okay, okay, and then okay, formal method in software engineering. Okay. When you talk formal method in software engineering, it involves formalization. Formalization. Uh, okay, what to be formalized? It is it is the common question. What is a formalization for formal method? First one is the model of requirement knowledge. So we can reasoning about the system requirement, and then after that we are looking for the specification and requirements. So we can document it, the specification very precisely. Okay, okay, this one what to formalize? We formalize the modeling and evaluation. Okay, so we can model each step step yang this one I have explained. We have four stages from informal, low, medium, and high. Okay, and then specification of program design, so we can verify the correctness. So we can verify the correctness, especially to remove the or exclude the module or function in the design. Okay, to remove or to exclude module or function. Okay, before this, the slide before that, I explained to you what is formalization, and secondly, why we formalize the formal method. Okay, okay, why we formalize formal method? Yeah, firstly, to remove the ambiguity and improve the precision of the system. Basically, when you disambiguate the system specification and then try to articulate some of the abstraction, we need to have a very certain point to ensure the precision of the system is in the specific target or in the minimum requirements for the system to be correct in behavior. This one to also remove the flaw of the system. And then the second to verify the requirement that have been met. And this one is basically for the behavior of the system. And then for those for two discussion we have discussed, firstly to remove and then to verify. The reason about the requirement and the design is basically the property can be checked automatically lah, because we have model, we have use case and everything, and then test for consistency, explore and consequences lah. This one the reason to about the requirement and design. Okay, and then to animate or to execute the specification that have with visualization and validation, we need to visualize and validate the system requirement because of what? Because each phases need to be documented. Okay, and this one to help us to avoid overlooking critical issues. This one, okay, critical issues, and be able to record. Okay, record the various assumption. Assumptions and also decision making. Macam mana je decision? Macam mana padam? Decision. Okay. Okay. because we have to formalize eventually, anyway, need to bridge the informal world into formal machine domain. And then after we go by the world of abstraction, we go by the formal machine domain. That's why we use the Z notation to visualize, to animate the uh, critical issues that help the developer. Okay, so far do you have any question? Ada soalan ke sekat ni? Okey ke? Okay, why people don't formalize? Some of the formalization is very rigid. Very rigid that include too much detail. Every step you must documented each step, and then you must need to do some assumption, and then you need to uh, include the semantic and also the appropriateness of the system. Okay, this one is too meticulous, very meticulous, and then it include too much detail. Okay, and then formatted concentrate on consistent and correcting the models. If you have the models, and then after that you need to uh, correct again, and then it will take a lot of time, a lot of time, and then sometimes the model itself is not accurate, inconsistent, incorrect, or incomplete. This one is a very rigorous process. That's why we have to use the simple modeling techniques. And then some of the people will get confused when talk about the tools that are appropriate for the modeling and also appropriate for the behavior of the system, because uh, one system cannot match the other system. This one is different based on the requirement of the system. Okay, and then form method require more effort. That takes a lot of cost. Take a lot of cost, and then the payoff is considered deferred. Okay, because of this, this method are considered costly and unfeasible. Okay. Tak berbaloi sebab kita kena tengok balik satu-satu every model tu kita kena tengok, we need to seen every stages of the model. Okay, and then three traditional approach that normally we use in a formal specification language. First one example is we go by the Z notation, and then VD and Vienna development method, and then sometimes we use large CH large model. This one is to closely, okay, to uh, to use this program semantics. Okay, all of these need you need data, basically data and model, and also model. Okay, and then secondly, reactive system modeling to formalize dynamic model. For example, we have a real-time embedded control system that I have explained to you. For example, we have automotive like brand like Tesla and then BMW and so on. We have automotive industry. We need to have a very rigorous process to ensure the safety and be able to have at the same time be able to have the performance of the car lah. And then the key technology here, eventually we are looking for the consistency checking and model checking lah. This one we look for the abstraction model. Okay, and then applicable to requirement language developed specifically for formal specification. We have a state chart, we have RSML, partner stable, and SCR lah. Okay. And then thirdly, we have the capturing real world knowledge. Basically, we focus on the domain. Domain, and then domain here means that we focus on the main problems. Okay, and then we use in order to have the appropriate model, we use the first order predicate logic, and then we use the inference engine. And then we capture using tools. Example here we have Rex, Apprentice, RML, Telos, Albert 2, and so on. This one to conceptualize the model. Okay, and then formal specification method. We have four here. One, formal specification. Two, formal proof. Three, model checking, and four, abstraction. Okay, formal specification. Normally, this one I have described before. Is basically to translation non-mathematical description. For example, we have this one more on the graphics. Okay, graphics. For example, we have diagrams, we have table, we have natural language, and then it represent the high level behavior. This one in the four stages. This one is high level. Okay. It also represent a concise description of high level behavior and properties of the system using the semantic tadi. Kita akan gunakan semantic. And then well-defined language semantic support a formal deduction about the specification. And later we see the deduction. Okay, in inductive and deductive. Formal deduction. Basically, we looking for two types, inductive and deductive. Okay, and then a type of formal specification, we have this one is to visualize the system behavior using the mathematical modeling. We have a state chart, we have a VDM, we have Z notation, but in our class, we are looking more on the VDM and Z. This one is two formal specification. And then the property oriented use the necessary property to explain the system behavior such as axiom rules. Okay, this one is very basic in formal method. Okay, later we see what is axiom. Okay, axiom basically a statement or proposition. This one I think you have learned in discrete mathematics. Okay, what to describe is to describe the structure, to describe the structure of system or model. We have two here. First one is algebraic semantic, and two is temporal logic model. Okay, and then secondly, formal proof. Formal proof is essential parts because it describe and construct semantic manually, but usually constructed with some automated assistance. Okay, and then two general approaches that use here is first is temporal model checking, and then secondly is automated model checking. Later we see this one. And then this one is basically we are building a finite model that check the system properties. Either the system property is uh, is appropriate or not appropriate, based on two general approach. And then for the abstraction, abstraction is a representation of the program using a smaller model. This one I have explained to you before this, because we want to expand, and then we want the model much more smaller, because if we have a larger model, we unable to signify, and then we unable to detect the error. And then this one which allow you to focus on the most critical part of the system properties. And then getting the right level of abstraction is very important in a specification. And then for the mathematical model, we have system properties. Two type here. We have a continuous model, and then we have a discrete model. But here we are looking more on continuous model. And then formal specification process model is required to articulate the assumption. The assumption basically to reduce the cost, and then to reduce the error. Okay, where are formal method being applied? Normally, when you talk about the formal method, we talk about the formal verification. And normally, when we talk about the formal verification, it appropriate for the complex and large and complex system. For example, we have a train system, we have the health and monitoring system. It's very large, large, and then takes a lot of modeling and properties. Okay, and then this one is the limit, the limit of formal method. System will never made 100% secure lah. Okay, because of what? Because of the security of the system. Security of the system, and formal method will not break into this axiom. And then number two, assumption about the system environment is very hard to model the complex system because of what? Because it can violate some of the model. Okay, and then security is not either or the properties. Okay, because of the security is the major issues here. Uh, Formal method actually is very rigorous process. It takes a lot of password. It takes a lot of certificate and also biometric. In order to ensure the authentication of the system privileges. For example, we have system admin. System admin can allow only two users in one time. This one is very complex system. This one it takes a lot of effort. and this one is a very costly, costly system. Okay, I think that's all for today. Do you have any question? Ada soalan ke setakat ni untuk introduction of form method? Boleh? Nota semua saya dah upload. Nanti saya akan upload dekat Padlet lah. And then minta tolong kamu upload your own version in the Padlet. Nanti after this I will upload to YouTube. Okay, ada soalan ke setakat ni? Syaira okey? Akhir okey? Iza okey? Syafiq okey? Yes. Okay. Okay. Consistency checking means that you need to have a consistent. Consistent mean you have very pertinent level of checking. For example, you have user requirement checking, and then after that you have development or implementation model checking, and then this one is more on the abstraction. Okay, you have to have pertinent, which means that you need to have a lots of effort because we are modeling a very complex system, a very big and a very big scale of complex system. Okay, okay, welcome. Ada lagi?